In this lesson, we're going to be covering the strategy for factoring by grouping. So factoring by grouping is very commonly used when we have four terms. You'll notice we have four terms below. None of them are like terms, and typically you're going to see some sort of x cubed in the problem. So when we use the factoring by grouping strategy, our first step is to group them into pairs. And if your brain is thinking that this looks really similar to what we did when we factored trinomials, you're right. This is exactly what we did. So we start off the same. We have four terms, and we're going to factor out the greatest common factor in each one. Well, I noticed that numerically, x cubed and 5x squared, the greatest common factor number-wise there is 1. And I noticed that the most x's they contain is 2. So I can factor out an x squared in front here. So x cubed over x squared leaves me with just x on the inside. Then the 5 stays because the 5 isn't divided by any number in the bottom, and the x squareds cancel out. So in this first pair, I factor out an x squared, and I know that if I were to distribute back in, I would go right back to where I was in that first step. Now, as I factor a greatest common factor out of this second pair, my goal is to create in the parentheses for that second pair another x plus 5. So I really have to think hard about what I'm going to factor out of this second pair to make it match that x plus 5 parenthesis piece with the first pair. So here what I notice is that we have a negative 4x minus 20, and my goal is to turn that into an x plus 5. And I notice that if I factor out a negative 4 here, negative 4 divided by negative 4 is 1, so I'm just left with x, and negative 20 divided by negative 4 is 5. So by factoring out a negative 4, I'm able to get a matching parenthesis piece. Now, because these have matching parenthesis pieces, we can group the coefficient in front that we factored out together. So what we can say here is we can group x squared and negative 4 together. We can say, well, x squared and negative 4 are both being multiplied by x plus 5. So this is our factoring by grouping technique. It's basically utilizing part of our factoring trinomials trick to factor a 4-term polynomial. Now, what you need to really be on the lookout for with these are situations where you can factor further. And typically what's going to happen is you're going to have a factoring by grouping problem mixed with a difference of squares problem or a difference of cubes problem. So here, if you notice, we actually have a difference of squares right here. So keep in mind, if you have something with a squared left over, you need to investigate that and make sure that it doesn't factor further. This is a difference of squares because we have x being squared to create that first term, and 2 being squared to create the second term, and a subtraction in the middle. So if you remember from before, when we're factoring these out, we would take x minus 2 times x plus 2 to factor this whole piece of x squared minus 4 further. So we can factor that a little bit further using what we know about the difference of squares. And then from here, this x plus 5 just gets carried down. So here we were able to use the factoring by grouping trick, and then we mixed it together with a difference of squares problem to fully factor this polynomial to be x minus 2 times x plus 2 times x plus 5. So let's investigate this second factoring by grouping problem here. So here if I take a look, I notice I have 4 terms, so I know I'm going to use the grouping strategy, and I'm going to start by looking for the greatest common factor within that first pair. Well, both 4 and 8 are divisible by 4, and then I can see that they both contain at least an x squared. So I'm going to factor out a 4x squared in front. 4 divided by 4 is just 1. X cubed over x squared leaves me with x. And then negative 8 divided by 4 is negative 2, and the x squareds cancel. So here I factored out a 4x squared, and I ended up with x minus 2 in the parentheses. So as I focus on this second pair here, my goal is to end up with an x minus 2 in the parentheses. And what I notice is that here with this second pair, if I factor out a negative 9, well, negative 9x divided by negative 9 leaves me with x. 18 divided by negative 9 leaves me with negative 2. So I end up with x minus 2 inside of both sets of parentheses. And because of that, I'm able to group together the numbers out in front. So I end up with 4x squared minus 9 times, in parentheses, x minus 2. So that's saying that both 4x squared and negative 9 are being multiplied by x minus 2. So I used my factoring by grouping strategy to get to this point. Then remember, as I talked about previously, if you still have an exponent here on your x, you have to explore your other properties. And so here we're going to explore the difference of squares, because I can see that I have something that is squared, and I can see I have a difference. So what I notice here is that if I square root 4x squared, I end up with 2x. So I really have 2x here being squared to create that 4x squared. And then I can also see that 9 is a perfect square, so I can see that I really have 3 here being squared to create 9. So here I have a situation where difference of squares works. Here I have my a value of 2x and my b value of 3. So I'm going to rewrite this portion to be 2x minus 3 times 2x plus 3 using the difference of squares strategy. And then I'm going to carry down this x minus 2 that came out as a result of factoring by grouping. So here is my final factored form where I used grouping and the difference of squares to reach a fully factored polynomial.